Assalamualaikum and a very good morning to our fellow students and viewers who are watching this live lecture on our official Asasi UiTM YouTube channel. Yang berbahagia Profesor Dr. Nafisa Muhammad Isa alias Osman, Senior Lecturer at the Department of Physics in Faculty Applied Science Universiti Teknologi Mara, Perlis Branch. Yang berusaha Dr. Nurul Raihan Muhammad Shuib, Physics Coordinator of Center Foundation Studies Universiti Teknologi Mara. Fellow students, welcome to the Professorial Lecture Physics. Students, have you ever wondered how does a television set, stereo system, or any other electric appliances works? What provides the power to operate them? You will find the answer to this question throughout this lecture session. So, stay tuned. Before that, let me introduce you to our speaker today. Professor Dr. Nafisa Muhammad Isa, alias Osman, completed her PhD at Universiti Kebangsaan Malaysia in 2010, where she also completed her master degree in 2002 and bachelor's degree in 1990. She has been a secretary of the Malaysian Solid State Science and Technology Society since 2016 and a member of Malaysian Association of Hydrogen Energy since 2017. Her research lies in advanced materials, solid state ionic and materials chemistry. She leads the Physics and Chemistry Materials Research Group and Proton Conducting Fuel Cell Research Group in UiTM. Her works mostly have been internationally and nationally cited, and the number of citations based on Google Scholar is about 441 with an H index of 10. She actively presents her research at international and national conferences in her study area. Her recognition also extends to the area of teaching, learning, and services to the university. Without further ado, I would like to invite Professor Dr. Nafisa Muhammad Isa alias Osman to deliver her lecture today entitled Alternating Current. Prof, the floor is yours.
Thank you. Thank you very much for the Putri Nosafura for the introduction. First of all, let me go for my slide presentation first. Okay, showing this poster because it's very nice poster to appreciate for the Pusat Asasi. Okay, to highlight this poster. Okay, thank you very much for this nice poster for the Syarahan Professor Physics under the topics of alternating current. As mentioned by the is it Miss Putri? Madam Putri, I got know about the title. Okay. Actually, I'm from the University UiTM Perlis branch. This is the enter of our campus. Very nice campus, green campus. Okay. Now we are looking for the green campus. UiTM Perlis is one of the green campus for the UiTM. Okay. My name is Professor Dr. Nafisa Osman. As mentioned, I have two groups actually in UiTM. The first group is known as Physics and Chemistry Material Research Group that registered in UiTM Perlis, and the second one is the Proton Conducting Fuel Cell Research Group. That one is under EK4, registered in UiTM Shah Alam. Means that for me, I in terms of research, I belong to UiTM Perlis and also to the UiTM Shah Alam. Okay. So the given topic to me is under week 9. Maybe for the Pusat Asasi, you're already in the week 9, but for degree student, we just only start this week. This is the week 1 for the degree student. Okay, in UiTM Perlis, we also have degree in physics. Okay, so I'm teaching for the degree in physics under the quantum physics. Okay, so actually for the electric and electromagnetic or for the alternating current, I quite not teaching this code quite long because I'm teaching more on the quantum physics. Okay, however, this is the subtopic that given to me under the alternating current. Is it my voice clear?
Yes,
Is it my,
Prof. Yeah.
okay. This is the six subtopic that given to me is the resistor in AC circuits, capacitors in AC circuits and RC circuits, inductor in AC circuits, RL circuits, RLC circuits, power in AC circuits, and resonance in series RLC circuits. Just to highlight to the student, actually this is the fundamental study on the alternating currents circuits. Normally the student don't know what is the application for this fundamental study in terms of electrical parts. Okay, I'm happy to highlight that this is a very significant topic when you want to study the interaction between electricity and materials. Okay, for my PhD student, when they want to go for the research on the interaction between electricity or current to the materials, they have to build the circuits. Okay, and the circuit that we use is RLC circuits. If we don't have the fundamental study on the alternating current circuits, we cannot go for the research on the. But my research actually on the solid oxide fuel cell that generate power. That means we have the some material that can produce power. Means that we need to know the electric circuits. Okay, so the most common use electric circuits, or we call as the equivalent circuit, is RLC circuits, and the important parameter in that research is the impedance. So means that when you do the research in at the level of master or PhD, then you can realize that the circuits is very important. Normally at the diploma or the matriculation or the SPM, the student don't know why they need to study these types of fundamental subject. Okay, but when you at the level of PhD student, then you need that this particular knowledge in order to understand the field of nanotechnology. Okay. So as mentioned just now, the alternating current generator, before we go for the circuits, okay, either the circuits element in the AC circuits, we have to know what is the alternating current generator, because that generator will generate current, and that current will flow through the resistor, capacitor, and inductor. So this is the just to give what we call basic knowledge on the alternating current generator. I feel that you already studied this one. Means that starting with the alternating current generator, we can have the what we call we will go for the circuits element connecting to the current generator. You can see that the current for the alternative current generator, we will start with the flux. Okay, means that a flux come from the electric fields. Okay? Electric fields, when you mix the certain area, you will produce the flux. Okay, this is under the basic fundamental knowledge in the physics for the electric part. Okay, the fluctuation of the magnetic flux will produce the EMF. So this EMF that produced during the fluctuation of electric fluctuation of the electric flux. Okay, so will produce the alternative current generator. That's why when you see the derivation of the equation now, you can see that the E here means the EMF, okay, that produced from the generator. And this voltage or EMF is depend on the frequency. That's why based on this equation, the output, okay, the words output here, The output of an AC generator is sinusoidal and varies with time. Okay? The definition for the alternating voltage and current here means that it comes from this graph ataupun it comes from this figure. Okay, so it means that before you can go deep on the understanding on the output of AC generator, you have to understand this one. This is the physics behind the alternating behind the AC generator. Okay, so there are a few quantity, the important quantity, physical quantity in the AC generator, which is the flux magnet. Okay. So I don't want to go detail on this one, just to show you what is the knowledge that you have to know when you want to study the AC generator. So based on this equation, delta V equivalent to V maximum sine omega T. This is omega. Actually, this equation comes from this one. Okay, when you derive the equation of the flux magnet to get the EMF from the Faraday's law. So those students, if you just know the equation without knowing how you can get the equation, it's quite hard you to get a basic knowledge to strengthen your basic physics. Okay, that's why this equation, the output of AC generator actually come from this one. So always ask yourself how we can get the equation. So if you can derive the equation from the basic fundamental, basic quantity of physics, then you can smoothly go into the equation or into the output of the derivation. Okay, so this is the equation for the AC generator, V equivalent to V sine omega T. And as usual in physics, if you write down the equation, it must be followed by some the meaning of each of the equation. Okay, normally at the degree level, when they ask you write down the equation, the student just only write down the equation without giving the meaning of its symbol. Okay, itu dalam fizik tidak tepat lah ya. So when you write down the equation, it must be followed by the definite or the meaning of its symbol. Itu baru dikatakan fizik yang lengkap. At diploma level maybe quite okay, but at the degree level, it must be followed by the by the meaning of its symbol. That's why when you look at the very established book, all the equation by the meaning of its symbol. Okay. So if you ask me how we can get this equation, then you have to back to this one. You have to go for the alternating current generator, starting with the magnetic field and also the flux magnet. Okay, this is different between AC circuits and DC circuits. Okay, one example of the source for the AC current is the wall sockets. Depending on each country, different country, they will have different voltage and frequency. In Malaysia, we use 240 volt and 50 hertz. Sebab tu kalau you pergi luar negara, bawa kita punya penama elektronik daripada Malaysia, sometimes dia tak capable, tak boleh nak match ya, sebab di US dia pakai 60 hertz. Di Malaysia kita pakai 240 volt and 50 hertz. Sebab tu kalau you tengok soalan, kadang-kadang banyak dia pakai 50 hertz sebab this is under Malaysia punya voltage and frequency. Okay. So this is the to differentiate between DC circuit and AC circuits. Okay, this is a symbol for DC circuits. normally a symbol for the battery, and this one is the symbol for AC circuit. This one is the sinusoidal, the symbol of sinusoidal graph, means that representing for the AC circuits. Okay. So an AC circuit consists of combination of circuits element and AC generator or source. Okay, what is the circuits element? There are few circuits element, but the important circuits element for this subject is the resistor, capacitor, and inductor. So circuits element ni banyak, diode, transistor, also the circuits element. But sometimes the student quite confused. What is the meaning of AC circuits? Consists of combination of circuits element and AC generator. Circuits element tu apa? AC generator tu apa? Circuits element tu, the example of circuits element is resistor, okay, capacitor, inductor. So if you combine the resistor with the AC generator, that one become a resistor in AC circuits. Itu nama dia lah. Sebab apa saya stresskan benda ni, even though at the degree level, the students still confused. What is the meaning of circuits element? Dia tak faham apa itu circuits element. Ini saya, maybe you at the pusat asasi, saya mengajar budak degree. Sometimes dia orang dah confused. What is the meaning of circuits element? The circuits element tu is example yang paling banyak digunakan, or the very important circuits element is resistor. Second one, capacitor and inductor. There is just a symbol used. Different country they use symbol for the resistor. For example, this symbol used normally widely used in Europe, and this symbol is widely used in USA. Sebab tu dalam resistor pun sekejap-sekejap pakai symbol ni, sekejap pakai symbol ni. But when you connect this circuits element, this one we call as a circuits element, and this one we call as a AC generator. Okay, so when you connect this resistor to the AC generator, for this one, this is the resistor we call or known as a circuits element. Okay, circuits element or known as a resistor here. So when you connect this resistor to the AC generator, and this circuit is known as a resistor in AC circuits. Okay, so this is the voltage across the resistor. So sometimes the student also quite confused. What is different between the EMF from the generator, and what is different between what is the voltage across the resistor? There are different meaning between the EMF here. This is the EMF from the AC generator, and this is the voltage across the resistor. So means that we can measure the voltage across resistor by using, for example, voltmeter. Okay, but this is the voltage across the resistor, but this is the EMF that produced by the AC generator. Okay, when you connect the capacitor, for example, this one, you connect the capacitor to the AC generator. So this one is known as a capacitor in AC generator. And this voltage across the capacitor. Of course, we have to measure with the parallel connection. And when you connect this one and this one, you measure the voltage across the capacitor. So means be careful with the voltage across resistor with voltage across the capacitor. But this is the simple AC circuits. You just only have the capacitor. Then you measure the voltage across the capacitor. If you combine resistor with the capacitor, so now you have two types of voltage. Voltage across the capacitor and voltage across the resistor. Okay, for example, this one, if you put the circuits element of inductor, you connect to the AC circuits, AC generator, and this is known as the inductor in AC circuits. Now, if you combine between R and C here, so this is when you measure here. So this is the voltage across the resistor, and this is the voltage across the capacitor. Why you have to understand this one? Because after this you will go for the phasor phase ataupun phasor diagram. That's why you will have the current like the voltage lead the current means that one belong to the connection of the RC in the AC circuits. So before we go detail on that particular subject, for the first time you have to understand the connection first. Connection ni nama apa? Connection ni nama apa? Okay. So for this one, for example, if you connect R with L here, so now you can see the change of name for the circuits. Okay, the name of circuits, if you want to name the circuits, it depends on what circuits element you connect. You connect the R to the AC generator, and this circuit is known as a RN in AC circuits. So it quite complicated compared to the one circuits element. Lagi banyak you letak circuits element in the circuits, okay, means that the calculation or the output of the circuit become more complicated. Okay, for example, this one, you connect the R here with the capacitor here and also inductors. So now you have three circuits element that consists of inductance, resistance, and capacitor. So now you have this circuits element is known as a RLC in AC circuits. But this is just only the series connection. But based on the syllabus that given to me, most of the connection is in series. But somehow we also have the connection in parallel. But Cik Putri just give me the connection in the series shape. Okay, so now you can understand the connection of the circuits element into the AC circuits. So different element you will name different circuits. Okay, so now you have the RC circuits. In short form, we call as RC circuits, RL circuits, and RLC circuits. Itu yang di-dividekan di bawah tu circuit-circuit yang berbeza. So for example, this one, we start with the resistor in AC circuits. Okay, since this circuit has a resistor, the current is given by this equation. Okay, because resistor in AC circuit, if you back to this equation, this diagram, this circuit just only have the resistor, which is R. Okay, that's why in this part it's mentioned that since this circuit has only a resistor, okay, the current is given by this equation. This is a very simple because resistor is not depending on the frequency. Okay, based on this diagram also it's clearly shown you that this is the resistance, okay, and this is the frequency. At all the frequency range, the value of resistance is the same. Means that the resistance is not depends on the frequency. Itu the paling simple lah. That's why they kata the resistance in a purely resistive circuit has the same value in all frequencies. So that the equation is quite simple because resistance is not depending on the frequency. Kalau resistance is depending on the frequency, the name is changed to become a impedance. Selalu student dia confuse, dia kata kat saya kenapa nak suka berubah-ubah dia punya nama. I'm always give example to the student. For example, you have padi, padi. So bila you ada padi, semua orang tahu padi. Bila you buang kulit dia dah tak jadi padi, you panggil dia beras. Okay. But the beras same from the padi, right? Because you just buang kulit dia dah jadi beras. When you masak that beras, okay, dia dah jadi nasi. So the name and the function of the circuits also can become different if you go for different conditions. Okay. So kalau macam ni, kalau katalah we go for the resistance, okay, bila resistance itu tidak depends on pada frequency which is the standard one that already study during your form 4 or your form 5, okay, you already heard about the resistance, because the simple one is resistance. Okay, bila dia tak depend on frequency, kita panggil dia resistance. But when the resistance rely on the frequency, we cannot set more the quantity as a resistance anymore. We have to state that one is the impedance. Okay. Okay, so this is dan kita nak tengok juga in term of phase. For a purely resistive circuits, the current and voltage are in phase. Macam mana kita nak nampak dia in phase, ya? Sebab you tengok kat sini, this is the AC generator. Okay, AC generator flow through the resistor. Okay, based on this equation, you can see that I directly proportion to the V. Okay, you nampak clear dekat situ. So you nampak bila voltage kosong, zero, current pun zero. Kalau kita nampak voltage kat sini zero, kalau you baca dekat sini pun zero, current pun zero. So bila voltage maksimum, current pun maksimum. So bila dia lalu sini, you dapat kalau sini maksimum, you akan dapat maksimum sebab dia kaca off. Okay, the vibration to produce the frequency, the 50 hertz is not affected by the R here. R here is not affected by the frequency at the AC generator here. Okay, so it means that when the voltage zero, the current also zero. Jadi bila dia sama macam ni, maka kita panggil dia in phase sebab dia sefasa. Okay, kalau you tengok ini, the current and the voltage are in phase. They are simultaneously reach their maximum value. Kalau dua-dua maksimum, kalau voltage maksimum, current pun maksimum. Kalau voltage minimum, current pun minimum. They simultaneously reach their maximum values, their minimum values, and their zero value at the same time. That's why we call as in phase. Yang ni saya rasa tak ada masalah. Dia simple lah untuk R in AC circuits. Okay. So now kita tengok the instantaneous value of the voltage or current represented by phasor and its projection on the y-axis. Ini dia punya, macam saya kata tadi, how to reflect this phase ataupun this current and voltage in term of the phase diagram, phasor diagram. To account for the different phases of the voltage drop, vector techniques are used. Normally, because when you study the electric part, we cannot see by our eye the what happened inside at the atomic or at the molecule level. That's why we have to use the wave, and that way we have to use the vector to representing the direction and the magnitude of the alternative voltage and current. Itu biasalah, because actually somehow we always heard about the mathematics is the tool to study the physics. Jadi nak picture tu, kita sometimes we have to use the mathematics, for example the trigonometry calculus vector. Okay, to account for the different phases of the voltage drop, vector techniques are used. Represent the voltage across each element is called a rotating vector, and this known as a phasor. The diagram is called a Profesor diagram. Ini dipanggil Profesor diagram lah. We start with the first quadrant, okay, second quadrant, third quadrant, and fourth quadrant, depending on the direction of the alternative current lah. Sebab alternative current tu dia one complete cycle dia 360 darjah. That's why we have the 4 quadrant. In order to represent the direction, we have to go for the vector techniques. Okay. In order to visualize the phase relationship between the current and voltage in AC circuits, we define Profesor. Vector whose length is the maximum voltage or current, and which rotate around an origin with the angular speeds of the oscillating current. Sebab dia rotation angular speed, that's why we use the angular displacement here. Theta is the angular displacement lah, sebab kita pakai circular ataupun kita pakai rotation modes. Okay. So saya tengok So how to because dia sefasa kalau kita tengok sini dia sefasa, okay, dia nampak dia punya fasa diagram pun menunjukkan dia adalah sefasa, which is I maximum in phase, I is in the same phase with the voltage. So in order to calculate the value of current and voltage, okay, so we have to use this equation. Normally we represent the current and voltage in the AC current using the RMS, root mean square. What is the meaning of root mean square? The root mean square current is a DC that dissipates the same amount of energy in the resistor that is dissipated by the actual AC. Normally dissipated by heat lah, sebab tu you biasanya akan dapat resistor tu panas. Kalau lama you connect with the generator. The RMS current is related to the maximum value of the AC which is the I maximum divided by this equation. So I RMS is equivalent to the I maximum divided by square root 2. This is the normal equation, general equation for the RMS current. Okay, and this is the normal equation for the RMS voltage. I don't want to go deep this one because maybe Dr. Puan Putri can give you more detail during the tutorial, because this is already, I think this is already done during your previous chapter maybe. I don't know what because this chapter 9 kan, saya pun tak tahu apa you belajar before this, because this is the simple equation for the resistor in AC circuits. Okay. This is the power. Okay, of course, from when you have the energy or you have the voltage, we can calculate the power. Okay, the rate at which electrical energy is dissipated in the resistor we call as a power. Ini satu lagi term yang selalu student confuse when we dealing with the rate. Okay. So the rate of energy, the rate of the electrical energy, okay, the rate of electrical energy, actually the power. Ini term yang sampai sekarang pula most of the student quite confused. I can give you one example here, because in physics normally the term is very important. We cannot simply use the word without knowing the meaning, because the rate electrical energy, normally not students say that one is belong to the energy. Actually this is not belong to the energy, it belong to the power. For example, in mechanical, you already heard about the momentum. Momentum kita tahu P sama dengan mu. The change of momentum, when you put the word change, the change of momentum is become mv tolak mu. Dia bukan momentum sebab momentum is mu. But the change of momentum is mv tolak mu. the rate of change of momentum now become mv tolak mu divided by t. So the rate of change of momentum actually is the force. When the question asks you calculate the rate of change of momentum, means that they ask you about the force. Tapi student banyak bagi momentum. Actually dia bukan minta momentum, dia minta the force. Similar with the power. When they ask you to calculate the power, this is the direct question, the power of electrical. Then you can use P sama dengan IV. Okay, but when they ask you the rate of electric energy, okay, the rate of electrical energy, the rate mean time, is involve time. So dE divided by dt is become power. Okay, so that's why the rate at which electrical energy is dissipated in the resistor, or sometimes we call as the power loss, P sama dengan IV. So we know that I sama dengan V sama dengan IR, so dia akan jadi I square R lah, itu standard lah. Okay, so ini pun tak ada apa. So by calculating the power and the finding of rate, we can see this equation. So now you can see that this is the normal P sama dengan I square R ataupun P sama dengan IV. But in term of the alternating current, then you have to back to this equation. So bila you pakai alternating current, so actually I sama dengan I maximum sin omega t. Okay, when the sin become 90 degree, so I is actually the I maximum. Ini dia punya equation lah, equation wave. Equation wave ni kita kena faham balik lah equation untuk mechanical wave. The wave ni dia ada banyak lah. So dia boleh pakai untuk mechanical wave, electrical wave, dia boleh pakai untuk metal wave. So nak faham electrical wave, dia kena faham juga mechanical wave. So bila sin what happened to the quantity in front of the sin, one y cosine maximum what happened to the quantity. So ini pun student dekat degree level pun still confused. Why sometimes the book they use sin, why sometimes the book they use cos. Itu pun ramai yang selalu confused. Sekejap nampak sin, sekejap nampak cosine. Itu pun kadang-kadang ada sin, ada different phase dia kat situ. Ada plus juga phi. Itu pun ramai lagi student confused. And when you cannot differentiate why at certain time you have to use sin, at certain time you have to use cosine, it's very hard to you to study the metal wave under quantum physics. But the quantum physics still use this basic of the equation. Okay, so kena faham lah, kadang-kadang kena tanya kenapa buku sekejap pakai sin, sekejap pakai cos, itu kena tahu jugalah. So dealing with the alternating current or alternating voltage means that FFS given by this previous equation, we can see that the V is equivalent to V maximum sin omega t. So you just substitute the value of V to the V sin omega t. Okay, so the current also now become the I equivalent to I maximum sin omega t. So itu you masuk just dalam equation ini je lah. Okay. Kalau you tengok P sama dengan IR, so this is I actually the I maximum sin omega t. So ini kita dealing with the alternating current lah. Okay. So itu pun saya pun tak nak lama lah kat situ, itu you boleh tengok kemudian. Okay, so now Ohm's law for the AC circuits. Okay, biasanya kita guna Ohm's law untuk DC circuits. But when you want to use Ohm's law for the AC circuits, okay, so we have to use this equation. Okay, So Ohm's law for a resistor in AC circuit is write down as the delta V RMS equivalent to I RMS R. Kalau you nampak ada RMS ni dia equation to calculate the resistor in AC circuits using Ohm's law. Okay. Jadi sebab V sama dengan IR tu itu memang Ohm's law lah. Tapi biasanya kita guna Ohm's law untuk DC circuits. But if you want to use Ohm's law for the AC circuits, the equation becomes V RMS equivalent to I RMS times R. Okay, ini dia kenapa nak pakai RMS, dia akan berbalik kepada yang ini tadi. By definition. So somehow the equation also needs to be tally with the definition. Sebab tu you belajar fizik dia suka tanya define. You selalu bising lah kenapa nak define, because without defining the concept we cannot go for the equation. The equation needs the definition, and from the definition we can go for the equation. Dia dua benda yang mati isi dengan kuku. Dia mesti faham equation, faham definition, then you can go for the detail on the physics behind the phenomena lah. Sebab this is the phenomena of the alternating current. Okay. Alternating current ni dia observe, we can observe the current. So when you observe the current, so what is the physics behind the current? Itu kita kena balik lah. Current tu dia datang daripada mana? Dia datang daripada charge. Itu dia jadi, nak faham alternating current tu actually you have to back to the basic physics quantity which is charge. Okay. Itu dia dalam capacitor nantilah. Okay, ini kalau you plot, ini AC current. So this is the notation that used in your subject. Okay, now back to the charge dalam AC circuits ni, we go for the capacitor in AC circuits. So what is the capacitor in AC circuit? Then you have to back to the circuits. The circuit just only consists of AC, generator and capacitor. Okay, itu saja yang dia ada. So nak faham dia pula, then you have to nak faham the what happen when the current from the AC generator tu dia goes into the capacitor. So now we have to go for the charge and discharge capacitor. Sebab because when the current goes inside the capacitor, flow inside the capacitor, so we can measure the voltage across the capacitor. So the voltage across capacitor itulah yang kita nak tentukan dia punya nilai dia. Okay, so consider a circuit containing a capacitor and AC source. Ini saya dah tunjuk awal tadi. You just imagine that in this circuit just only have the capacitor. Now we have to understand the characteristic of capacitor in order to understand the voltage across the capacitor. The current start out at a large value and charge the plates of the capacitor. We start with the empty capacitor. So for the empty capacitor, when you flow you connect the capacitor to the generator, AC generator, the current, especially I is the current flow from the AC generator into the capacitor. Ini ramai student confused sebab dia ambil current yang keluar daripada capacitor. Actually that current is measure, yang kita measure tu current from the AC generator to the capacitor. So pada mulanya capacitor tu dia kosong. So of course the current will smoothly flow into the capacitor. Okay. Lama-lama bila capacitor tu dah penuh, the current from the AC generator cannot flow into the capacitor anymore. Masa tu dia contradict. When the voltage across the capacitor maximum, the current minimum. When the voltage across the capacitor minimum, the current is maximum. So dia ada lag kat situ. So means that voltage and current lag each other. Sebab tu you akan nampak in the circuits of AC connect to the capacitor, the current lag to the voltage by 90 degree. Kenapa dia lag kat situ? Sebab ini mudah cakap ya. Mudah cakap nak bagi faham. Bila kita imagine you charge handset. Okay. Saya suka bila explain dalam bahasa Melayu sudah senang faham. Bila handset you kosong, jadi dia masuk cepat. Bila handset you dah penuh, current dah tak nak masuk. So bila masuk dia, when you measure the voltage across the capacitor maximum, the current become minimum. Sebab current dah tak boleh masuk. The current tu bukan current yang dalam this inside the capacitor, but the current flow the AC circuits. So that's why satu maximum, satu minimum. In terms of a representative vector, in order to say that one maximum and one minimum, we go for the lag. Okay. Jadi as the current start out the large value and the charges the plates of the capacitor. There is initially no resistance to hinder the flow of the current while the plates are not charged. Jadi waktu tu kita punya capacitor kosong, so the current easily flow inside the capacitor. As the charge on the plates increases, the voltage across the plate decreases. Jadi and the current flow in the circuit decreases. So now you can see opposite. One increase, one decrease. So this is to give you some idea why the words of lag. So current lag the voltage or voltage lead the current. So dia ada by 90 degree sebab satu naik satu turun in term of vector representing by y-axis and x-axis. Means that lag and lead by 90 degree. Okay. So see, this is the example show to you the capacitor in AC circuits for the equation to what is the voltage, okay, for the capacitor in AC circuits. Yang ni pun saya tak nak lama. So how to calculate the what so called as a resistor in the capacitor, okay? So in the capacitor, we do not call that one as a resistor or representing by R. Okay, so the resistance in the capacitor is known as a capacitive reactance. Jadi kalau dalam resistor kita kenali sebagai R, kalau dalam capacitor that resistance is known as a capacitive reactance. Kalau dalam inductor is known as a inductive reactance. So jadi analogy with the Ohm's law, okay, I sama dengan V divided by R. That one is under resistor. But for the capacitor, we use I equivalent to V divided by XC. So XC is known as the reactive capacitor. Why it changed to the RC? Because this capacitor is rely on the frequency. Okay, it's rely on the frequency. So we have to modify the equation of the resistor to the reactive capacitance for the capacitor using the equation of XC equivalent to 1 divided by omega C. Ini kenapa nak faham balik kenapa itu dia kena berbalik kepada the characteristic of capacitor. So that one we have to understand what happened inside the capacitor, or we call as the characteristic of the capacitor. Kena faham capacitor tu apa ada di dalamnya dulu, baru kita boleh faham what happened to the capacitor when we flow electricity inside the capacitor. So masa tu dia akan berubah sedikit lah. Macam saya kata tadi lah, bila padi tadi you buang kulit tu dia menjadi beras. Bila you masak beras tu dia menjadi nasi. So bila dia masuk dalam capacitor, we cannot call that one is a resistor. We have to call that one is a capacitive reactance. Okay. Ini nanti you boleh tanya lecturer lah. Dia berubah kat mana tu. Okay. So this is the graph to show you the depending of the capacitive reactance to the frequency. Okay. So for the resistance, you can see that the resistance is the same. dia mendatar. But for the capacitor, or we call it the capacitive reactance, it totally rely on the frequency. Okay, this is a very interesting part because the depending of the capacitance can give you more detail on the characteristic of the material. So that's why saya kata kena faham character of the capacitor in order to understand more detail on the behavior of the capacitor when we flow the AC voltage. Okay. So this is the equation. Okay. So XC is the capacitive reactance equivalent to 1 divided by 2 pi C ataupun omega C lah, because omega equivalent to 2 pi F. Okay. So macam mana nak faham lag and the lag or the lead of current to the voltage. Okay, back to the equation again. Okay, this is the VC we call as a potential difference across the capacitor. So what is the meaning of voltage across the capacitor? Balik pada gambar ajar the first tadi, when we measure the voltage across the capacitor, dia bukan voltage yang dekat generator tu, itu voltage of generator. Ini potential across the capacitor. So this is the equation that you already know. And when you're dealing with the capacitor, now we have to back to the Q, because the equation for the capacitance is the capacitance equivalent to Q divided by V. So this is the capacitance. So we have to use this equation because we're dealing with the capacitor. The physical quantity for the capacitor is the capacitance. So the capacitance is Q divided by C. So you can see that the equation, and because we're dealing with the current, so we have to change the charge to the current. So how to change the charge to the current? Because current is the flowing of charge. Okay, kalau you ada charge, ini pun ramailah bila disebut static charge, dia boleh kira nilai current. Current you tak boleh kira kalau charge tu static. The charge must flow because the definition of the current is the flowing of charge. Jadi kita kena kacau sedikit lah equation ini supaya dia menjadi current, ya. So that's why I is the rate of flow of charge. So you akan nampak lah the rate of flow of charge. Jadi you mainkan equation ini. So bila you mainkan equation dia, ni saya tak nak detailkan, but you can see that the step of derivation for the equation in order to show you why the current lag to the voltage by 90 degree. So somehow that one can be more understand if we can go for the equation. So bila you tengok equation ni, we start with this one. Ini simple equation saja. VC sama dengan Vm sin omega T. So how to inject the voltage, the charge or the current, okay, inside this circuits that consists of the capacitor. So you main lah equation dia. So by using this one, dan you differentiatekan dia. Bila you differentiatekan dia, you masuklah nilai trigonometri ke apa you masukkan, you akan dapat macam ni lah. So ini ada omega, that's why you datang mana omega tadi kan. Capacitive reactance 1 divided by omega tadi. So omega ni datang sini lah sebab you differentiatekan sin omega T, you akan dapat omega cos omega T lah sebab sin you akan jadi cos. So you mainkan equation now, you can see that now I just want to show you, look at the equation 2 and equation 4, equation 7. Equation 2, VC ni means that a voltage across the capacitor. I is the current. So you can see that there is sin omega T without phase here. This is omega T plus pi divided by 2 here. So dia ada beza dekat sudut ni. Ni omega T without phase, and this is omega T plus phase. Dia nampak kat sini kalau kita kata kosong, omega T plus 0, sini omega T plus pi divided by 2. Pi divided by 2 is 90 degree. So kosong dengan 90 degree tu macam mana? Kosong dengan 90 degree tu dia dia macam ni lah. Ini 190 degree. Okay, kita tengok 190 degree. So satu minimum, satu maximum. Inilah by looking at the equation 2 and 7. Okay, kalau V dia kosong, I dia akan jadi maximum. Itu yang you akan keluar nanti, dia akan sebut the voltage and current in the capacitor are not in phase. Not in phase. Sebab apa not in phase? Sebab by equation clearly shown you they are not in phase. Kan, dia is not in phase. Tu kalau kata kita tak ada equation tu susah nak nampak. Sebab tu in order to understand more physics, we have to go for the mathematics to help us. Okay, so by looking at this equation 2 and equation 7, clearly show you that they are different phase. Okay, they are not in phase. Tapi kalau resistor tadi dia are in phase, you try derive the equation, you akan nampak voltage and current are in phase. But this is clearly show you they are not in phase. So in order, kalau dah dapat equation dia, then you can draw the graph, the sinusoidal graph. One is the sinus graph, one is the cosine graph. This is the cosine graph actually, that's why you have to put the pi divided by 2. Sin omega t plus pi divided by 2 actually is the cos omega t. Itu pun kena faham maths je lah. So satu graph sin, satu graph cosine, which is clearly show you they are not in phase. That's why the voltage and the current in the capacitor are not in phase. Ini yang ramai student tak apa nampak, tak apa clear without derive the equation to show you they are not in phase. The voltage lag by 90 degree. So why 90 degree? Because this is the clearly show you the angle is 90 degree. Pi divided by 2 is 90 degree. So macam mana dapat ni? So you have to go for this equation. Then it give you they are different about 90 degree. Itu yang datang 90 degree. So they are not in phase. You tengok kat sini. Kalau yang hijau ni maximum, the current become minimum. So they are contradict each other. Ataupun dalam bahasa ni dia panggil phase diagram ni, dia are different in term of 90 degree lah. Okay, itu bermaksud dia kat situ. Okay, the graph show the ini just explanation. I think the explanation that you can to give you more detail what is the meaning of a voltage like the current. Ini saya rasa Puan Putri dah explain lah. Dia explain satu-satu kat sini lah. So saya itu dia punya explanation in term of sentence. But just imagine that when you charge the capacitor, when initially the capacitor is empty, the current easily enter to the capacitor. Time by time, the charge inside the capacitor become increasing, so the current outside the capacitor cannot enter to the capacitor. So that's why the voltage across the capacitor become maximum, the current become minimum. Itu samalah ayat yang panjang-panjang ni. Okay. The impeding effect of the capacitor on the current in AC circuit is called the capacitive reactance. Impeding effect tu lebih kurang resistance. Impeding ni dia menghalang lah. Jadi kesan halangan itu dalam bahasa mudahnya disebut resistance lah. But in term of the capacitor, as I mentioned previously, we do not call as a resistance, but we call as the capacitive reactance. But even though you call as a capacitive reactance, but it's still under the impeding effects. Okay, so the impeding effect of the capacitor, dia tak sebut resistance, dia sebut the impeding effect. Actually, resistance also impeding effect juga, kesan halangan of the capacitor on the current in the AC circuits is called capacitive reactance, and the symbol for the capacitive reactance is the XC, and given by the equation 1 divided by 2 pi FC ataupun omega C. So macam mana dapat omega C, you boleh tengok kat sini lah. You boleh tengok kat sini macam mana dia dapat omega C. So omega ni omega C ni capacitor actually come from the equation of the capacitance. Capacitance equivalent Q divided by V. Itu yang datang C tu. So you differentiate kan, you akan dapat omega C. Okay. So omega ni actually come from the frequency of the AC generator. Itu yang datang omega C itu. That's why the equation of the capacitive reactance is 1 divided by 2 pi FC. Okay. Ini sama angular frequency 2 pi F, and this is the Ohm's law for the capacitor in AC circuits. It's become IRMS XC. Okay. Tak ada apa. And this is the RC circuits. Okay. Ini yang dikatakan in term of the Phasor diagram for the RC circuit, the voltage across the capacitor and across the resistor are 90 degree in the diagram. Tadi diagram untuk C in the circuit that consists only C. Now if the circuit consists RC, so this is known as the RC circuits. Saya kata tadi lah, dia ada RC circuits, RL circuit, RCL circuits. So if the circuit consists of RC, so you repeat the same step between the circuit consists only R, the circuit consists only C. Then you repeat the same. Then you can get the Phasor diagram for the RC circuits. Ini pun you akan nampak dah, dia lag 90 degree. Okay. And across this 90 degree. Ini 90 degree lah. Ini pun kenapa kalau you faham circuits that consists R and the circuit that consists C, then you can easily understand the circuit consists of RC circuits. Okay. So back to the vector again, the additional vector, how to calculate the V maximum based on this vector. So you have to go for the additional. So kita patah baliklah penambahan vektor. So bila you ambil balik penambahan vektor ni, ini match baliklah kan. So that this is the belong to the resistor, and this is belong to the capacitor. So by using the additional of vector, so you can have the equation of the V maximum. That one is look like hypotenuse or trigonometry equation for the additional of vector. Okay, this is the RC circuits. Okay, so because you have the one part that not depending on the frequency and the one part depending on the frequency, then that one we call as the impedance. That's why for the RC circuits, we normally know this one as a impedance. This has the exact same for the V sum equivalent to IR if we define the impedance. That's why for the RC circuits, because you have the what we call the vertical direction, you have the horizontal direction here, means that we have to go for the complex number in order to representing the equation for the RC circuits. This is actually a detail. If you detail to this one, this is conceived of the real part, and this one is conceived for the imaginary parts. Okay, so the real part normally is not depending on the frequency, is goes to the resistance, and the imaginary part is actually depending on the frequency, and this one is capacitance. So the impedance for the RC circuit can give you the value of resistance and the value of the capacitance. So ini that's why saya kata dia lagi banyak you masukkan circuit element, the equation become complicated. If you have the RC circuits, then you have the value of impedance. Though from that impedance you can extract the value of resistance and the value of the capacitance. This is a very interesting study in the equivalent circuits for the materials. So for each material we will have their resistance and will have their capacitance. So we can extract that value from the impedance based on the RC circuit. Then you have to know the connection, or to know the equivalent circuits ataupun circuits in order to calculate the impedance, because different circuit will have a different equation for the impedance. Okay, so ini pun just only additional vector. Okay, ini RMS saya pun tak nak lama kat sini. This is the inductance in the AC circuit. Okay, inductance for the AC circuits, as I just mentioned before, these circuits actually consist of the AC generator and inductance. So I think I have for the before that the voltage that flow from the AC generator to the inductors still same with the previous one, which is V equivalent to V maximum sines omega t. Okay, just as with the capacitor, we can define inductive reactance. Okay, but for the inductance, now this quantity is known as the inductive reactance, which is XL, and SL equivalent to omega L. So how we can get this equation? But I think maybe you already did have the equation for the inductance. Okay, but before we go for the alternating current, at least we know how to get the equation of the inductance. I think that one is maybe you already done in previous chapter, how to get the equation of inductance. Okay, otherwise we maybe before this we quite familiar with the resistance, we quite familiar with the capacitance. Maybe we do not familiar with the inductor. Okay, so inductor, we also have the equation for inductor. I can't remember what the equation of inductor, but okay, but maybe the previous guy you already have the equation for inductor. So when you have the inductor, so in order to get the impeding effect in the inductor, we call as the inductive reactance. Okay, so but you tengok unit dia masih lagi ohm lah. Even impedance pun unit dia masih lagi ohm, but that one is still under the resistance. Okay, so that's why the unit is ohm. Cuma nama dia berubah. Well, for the inductor, it is known as the inductive reactance, and SL equivalent to omega L. So means that the inductor still depending on the frequency. Okay. Kenapa frekuensi ni? Kenapa dia satu kuantiti yang penting? Maybe the effect of frequency is not significant when you dealing with the low frequency generator. Sebab kita pakai just 50 Hertz frequency generator, just only 50 Hertz. That's why the effect of frequency is not really significant. But when you dealing with the high frequency vibration, bila you dah main sampai gigahertz ataupun terahertz, so means that the frequency is very significant to the capacitance and inductance. Jadi benda-benda yang inductor ni dia akan nampak kesan dia bila kita dealing with the high frequency generator. So ini pun tak nak lama lah. Okay. Kat mana saya punya video tu? Before we go for the phase diagram of the inductor, I think better I show you what is the meaning of the inductor and what is the back EMF in the inductor. Tak ada ya.
Video YouTube Prof tunjuk tu ke? Saya attach dekat chat box ya. It's from YouTube.
You boleh tolong play tak? Saya kena stop
I believe.
I just want to show the meaning of back EMF before we go for the phase diagram, because that YouTube will clearly show you us the meaning of back EMF. Okay, saya kena stop kan? You tolong.
Want to pass your certification exams?
Sekejap ya, tengah nak play video tu.
Inductor is a very interesting device in that when you simply connect the DC.
Is it equal?
An inductor is a very interesting device.
Is it playing?
Stop, just stop.
Just stop. Sorry.
Cuba try tekan play lagi sekali.
Okay, kejap. I think I have to... Hold on, yeah. I think I have to present the whole screen. Okay. Hold on, yeah.
I'm trying to look in the equation to show the different phase between current and voltage in the inductor, but I just found the YouTube.
Alright, because I'm trying to play the video, but I need to go out from there because my MacBook dia macam kena ada authentication sikit. Hold on I'll try. Sekejap
I just want to show the student why there are different phase. Itu je kadang
inductor tu kejap.
Ya.
I authenticate dulu this one, and then dia akan automatic terkeluar, then I come back.
I just want to highlight the problem for the student during at the degree and master level. Itu yang saya rasa penting kot sebab the rest I think the all of you can explain to the student, but just to highlight sometime the student what the loophole of the student in terms of the basic in the alternating current during their master or PhD or degree study. So bila sometime at the degree level, when I say the current like to the water, they even know why they are like between each other. What happened to that at that situation? So saya kena ulang balik kat student. So to show them why they are like. After they are like or lead by 90 degree, then we have to go for the complex number. Okay.
Dia kena ada animation macam ni kan, baru senang nak faham.
You simply connect a DC power supply across it. It acts as a magnet. It has many applications across all engineering disciplines. Let's take a logical look at the physics behind inductors. A current-carrying conductor produces a magnetic field around it, as shown. Let's do an interesting experiment. Let's bend the wire. As you bend the wire, the magnetic field lines interact with each other and produce an interesting magnetic field pattern as shown. This magnetic field pattern is similar to that of a permanent magnet, which is why a current-carrying loop acts like a permanent magnet. Clearly, simply by increasing the number of loops, we can increase the magnetic flux. We can also increase this magnetic flux by increasing the current through the coils. A constant called inductance connects between the magnetic flux and the current's value. The value of inductance depends purely on the geometry of the coil. Now, for the most important part of this video. What will happen if the current through the coil changes? When the current changes, the magnetic flux that the coil produces also changes, which means we need to study the effect of this varying magnetic flux on the coil. To study the effect of varying magnetic flux on a coil, we need to introduce Faraday's law. The great scientist Michael Faraday said if the magnetic flux changes across a loop, it will induce an EMF across it. Here you can see that the permanent magnet approaches or leaves the loop. It will induce an EMF across it. This result occurs because the movement of the permanent magnet causes a varying magnetic flux on the loop. Now, let's apply Faraday's law to an inductor connected across an AC power supply. According to Faraday's law, the varying magnetic flux that the AC power source produces will definitely produce an EMF across it. This EMF is known as back EMF, and this phenomenon is called self-induction. The electricity we use everywhere is sinusoidal in nature. It's therefore very important to study the effect of a sinusoidally varying EMF across the inductor. You might have noted that in Faraday's law, everything is about the rate of change. So let's study more about a sine curve's rate of change. Clearly, for the sine curve, the change is zero when the current is at the peak, and the change is maximal when the current is zero. This is one interesting property of a sine curve. The EMF it induces is proportional to the change in current. Therefore, the EMF across the inductor is zero when the current is at maximum. And the EMF is at maximum when the current is zero. In short, the back EMF will vary as shown. If the resistance of this circuit is negligible, the EMF induced across the inductor should be equal to the applied voltage, but opposite in sign. So the applied voltage also has the same variation with the current. When the applied voltage is maximal, the current through a pure inductor circuit will be zero. And when applied voltage is zero, the current flow through the circuit will be maximal. In short, when a sinusoidal voltage is applied across a pure inductive circuit, The current will lag the voltage by 90 degrees. This is a crazy behavior. However, using the fundamental laws of physics, we have explained the reason behind it. We hope you have developed a good conceptual understanding of inductors. Thank you.
Yeah. Now you can see why the current and the voltage like within 90 degrees to each other. So this is under inductance, and why they are changing the direction, then you have to back to the Faraday's and Lenz equation. So itu yang dikatakan kenapa under inductance, why the voltage like the current 90 degree. So saya rasa that video is already explained. Because the first one in the capacitor, I'm explain with the mathematical equation to show you the 90 degree between the voltage and the current in the capacitor. So for the inductance, I'm already show you by this video why the current and the voltage are different 90 degree to each other. So hopefully that one can understand. Then we can back to our slide here. Saya rasa part tu yang selalu problem lah during degree level, why the current and the voltage are like to each other. Oh, this is the link for the YouTube. Sorry, tidak nampak. So now the graph show the current and voltage across in the inductor versus time in the AC circuits. Okay, this is the graph that already shown in the video just now. Okay, and the voltage reached its maximum value 90 before the current reaches its maximum value. So the voltage lead the current by 90 degree. So the current in the circuit is impeded by the back EMF for the inductor. So what is the back EMF is already explained in the YouTube. Okay. So the voltage across the inductor always leads the current by 90 degree. Itu yang tadi tu ditunjuk lead by the voltage. Kadang-kadang lead, kadang-kadang lag. Tengok siapa dululah. The voltage across the inductor always leads the current by 90 degree. If you want to put that the current across the inductor always lag the voltage by 90 degree. Itu term yang selalu kadang-kadang student confuse. Dia kata ada leads, ada lags. Jadi you baca siapa dulu. Okay, kalau you baca the voltage across the inductor always leads the current by 90 degree. Ataupun untuk inductor you boleh baca the current across the inductor always lag the voltage by 90 degree. Just a little twist in term of the sentence ataupun in term of the wording. Okay. The effective resistance of the coil in the AC circuit is called the inductive reactance. The one is under coil because this one is under solenoid. Okay. We have the north and south pole. So that's why the effective resistance of the coil in the AC circuit is called the inductive reactance. And that one is given by the equation of 2 pi FL or omega L. So dalam inductor, the effective resistance is called as a inductive reactance. Okay, omega L, and the unit still ohms because they also owe the resistance. Okay, but just change the name because that one is not totally a real resistance, but that one is the effective resistance. And that's why we call as a inductive reactance. So you know that the unit for L is the Henry, F for Hertz is senang kan, tak ada apalah. So Ohm's law. So how to calculate the impedance of the RL circuit? That one is the first one. The first one is the AC consists of the L's element. So now if the AC consists of RL circuits, okay, so the impedance for the RL circuits again, we back to the vector diagram here, okay, between the VR dengan VL. So ini ada VR dengan VL, so they are lead by 90 degrees. So in order to calculate the impedance, sebab apa dia panggil impedance? Macam saya kata tadi lah, bila resistance to the involved frequency, then we have to use the word impedance. So the impedance pun kadang-kadang ramai yang confuse what is the impedance. This is one topic during my PhD study. I'm focusing just only on the impedance. So in order to measure the impedance for the interaction, this is a very detailed interpretation of the impedance. That's why a lot of mathematics need to be there, okay, to study this is just only the simple circuit. But if you're dealing with the complicated circuits, so it's a very complicated equation or derivation to prove the impedance in the circuits of the materials. Okay, so in order to calculate the effective resistance in the RL circuits, then we have to go for the impedance here, Z impedance here. So that since this diagram, the vector diagram consists of the voltage across the resistor and the voltage across the inductor. So of course we have the value of R here and the value of the reactive inductance here. Okay, inductance here. That's why we inside the impedance, you have the resistor and the reactive inductance, which is RL. So macam mana dapat ini additional of the vector je lah. Okay, so ini pun simple je lah, additional of vector, because you already have the vector diagram here. Okay, Phasor diagram actually adalah dalam bentuk vector diagram. Okay, so inductor in AC circuits, okay, ni sama juga. Ni dia punya conclusion dia. You can see that if you have the current versus the frequency, okay, you have the current versus the frequency here. So since the resistor is not depending on the frequency, means that you have the constant value. Memang resistor dia tak akan depend on the frequency. Okay, so that's why you have the constant value here, because the resistor is not depending on the frequency. Sebab tu dia punya passive act dia frequency here. So I versus frequency, you have the constant value here. So nilai dia akan maintain. Okay, so if you're dealing with the capacitance circuits, the circuits element, okay, you can see that the capacitance is depending on the frequency. As the frequency increase, the capacitance also increase. As the frequency decrease, the value of inductance increase. So you can nampak kat sini lah. Okay, so this is also can represented by the equation. Okay, if you look at the equation of the capacitive reactance, capacitive reactance is 1 divided by omega C. So omega duduk di bawah So lagi besar omega tu dia punya lagi besar frekuensi tu, reactive reactance dia akan menjadi semakin kecil. So that one is only the equation to go for the relationship of the quantity. Okay, ini pun just mentioned just now. Okay, this is the only the additional of the vector. Okay, you can see that in order to get the V maximum here, we have to go for the additional vector between resistor and the capacitor. If you go for the 3 circuits element, so now you can see that for the 3 circuits element, you have R, you have inductance, and you have the capacitance. So means that, and in the Phasor diagram here, you have the direction for the capacitor, you have the direction for the resistance, and you have the direction for the inductance. So in order to to go for the additional vector for these 3 circuits element, we have to go for this one. Okay, this is the additional vector for the circuits element. Ini kita boleh combine lah because both of the capacitance and inductance are depending on the frequencies. Okay. And this is the detailed explanation given by the given in this slide about the current and voltage relationship in the circuits element. You boleh baca satu-satu lah ya. So I think that one is just only mathematics. Ini you punya lecturer boleh explain lah in term of mathematics. I just want to go what is the problem for the student at the high level when are dealing with the AC circuits. Normally just on the how the current like to the voltage by 90 degree. Itu dia orang kurang faham kat situ. If you can understand physics behind the lead or the lack of current, the rest is quite easy for you because the rest is just only mathematics to calculate the vector, additional vector. Tapi yang problem besar for the student is they don't know what is physics behind how to explain why the current like to the voltage by 90 degree. Itu yang masalah besar. Biasanya kalau saya boleh tangkap student tu faham that part itu, the rest tu become senang lah kalau student tu dia punya mathematics strong in term of vector and complex number. Again, if for the impedance, of course you have to dealing with complex number because we have the real part and imaginary part. Ini sampai PhD student pun sometimes they don't know how to solve the complex number of the imaginary part and real part because the real part is belong to the resistance, imaginary part is belong to the capacitor. Okay. Itu belum masuk lagi inductor because at certain condition when we dealing with the high frequency, the inductor, the circuit element of inductor comes in the circuits of the material. Jadi bila datang 3 tu, itu is more complicated lagi lah. But the most important thing, we can understand what is the inductor, the characteristic of inductor, the concept of inductor. So when we know the concept of inductor, you kacau macam mana pun in term of the inductor or in term of the arrangement of inductor, it's quite easy for you. Okay. Ini pun saya tak nak lama lah. Okay. So summary of circuits element, impedance and first angle. Okay. You can see here, as I mentioned you before this, this is the only for the RL, RC, RLC in series. There is no notes for the RLC in parallel. Normally, the most significant research we are going to the RL or RC or RLC in parallel. Okay, ini dia simple sikit lah. Okay, mungkin subjek you sampai series lah. But actually, whatever pun the student must understand on the simple one before you go for the complicated one, because I think maybe the syllabus not consist of the parallel, sebab parallel tu dia lagi banyak dia punya mathematics dia. So summary of the circuits element, impedance and the first angle. So this is the circuits element for the R. So the impedance actually known as R. Okay, circuits element for the C, the impedance is known as reactive capacitance. Circuits element R is the impedance is known as reactive inductance. But impedance ni R dia kat sini tak adalah, kosong lah sebab dia dah jadi reactive impedance. Okay, so when you have the RC, so of course you will consist of the R and C. You have R and L, of course you will consist R dengan L. Ini sebab dia simple, but you have the value, so we tak nampaklah kat mana real and imaginary. If you consist of RLC, this is the impedance. So jangan cari dia lah, kena cari impedance. So calculate the impedance of the circuits element that consists of the circuits AC circuit that consists of RLC. Salah lah kalau you kata cari resistance lah, but we have to go for the impedance. Okay, this is the first angles. Okay, there is no first angle 0 because they are in phase, but there's a fasa, so there is no. That's why kita nampak tadi dia tak ada sebab plus 0, I pun plus 0, V pun plus 0, so it means that they are in phase. But for the capacitor and inductance, they are lag by 90 degree and lead by 90 degree. Ini fasa dia lah. Okay. So ini pun tak ada policy power pun saya rasa tak nak ke, tak ada yang power ni just continuous from the current dengan voltage. Sebab if we can understand the current and we understand the voltage, the power is become easier because power just equivalent to IV. Okay. Sebab saya pun tak nak lama lah. Then you can see that okay, ada last one, ada satu lagi resonance. So when you have the circuits, okay, the another quantity is the resonance. So what is the resonance actually? When you have the reactive inductance equivalent to the reactive inductance, okay. So XL equivalent to XC, so maka dia akan dipanggil circuit tu berada dalam keadaan resonance, okay. So ini pun sama juga, dia punya teori dia for the resonance of the RLC circuits or RC circuit, just a very simple, okay. In order to get the resonance condition, RL must be equal to the XC. Kalau sudah dapat tangkap yang ni, the rest dia jadi senang lah, okay. Sebab resonance. Resonance ni apa pula nak cerita dia resonance, you pun dah belajar resonance kan. So the condition for the resonance is you have to know what is the condition for the resonance. So in term of these circuits, the resonance is SL equivalent to XC. Ini penting. Kalau tak faham ini, the rest dia tak boleh buat lah. So you akan dapat omega L sama dengan 1 divided by omega C. So omega sama dengan 1 divided by LC. So this is the important when you study under the subject of electromagnetic ataupun transmission of electromagnetic wave in telecommunication. Ini saya ada subjek tu untuk budak degree semester 4 So ini jumpa balik ni omega sama dengan 1 divided by square root LC. Okay, that one is the use of resonance phenomena in the telecommunication transmission for the under the transmission line, okay, under transmission line. Ini kita pakai balik lah. Okay. Jadi yang you belajar semua ni, kata nak guna apa mana, you akan nampak bila you buat you study wave, particularly for those are interested in the telecommunication area. Sekarang ni kan banyak IT kan. So siapa yang nak berminat nak ambil IT ke engineer dalam IT ke, so you cannot run or escape from the basic of electricity, okay? Basic of electricity and basic of magnetism. So dia akan ada satu lagi topik electromagnetism in the telecommunication application. Ya, ini banyak jumpa nantilah, okay? Jadi you jangan risaulah apa yang you belajar basic during your asasi ni, they are very useful when you go for the high level of education. Okay, so natural frequency on the RC scape ni, ini tak ada plus sangat So ya, itu je kot Yang lain doktor you punya lecturer boleh sambung lah. Okay. Ini dah ada dalam kuliah dah. Ya kot. I think I stop here because almost 2 hours lagi 15 minutes goes to 2 hours because I think that my lecture just only 1 and 30 minutes.
Okay, before we end our lecture, do we have any questions from the students? If you don't want to ask, maybe you can just type in the chat box. So everyone, or all the students understood the lecture? Because I didn't see.
I think the lecture is quite fast, because the basic one you have, of course, you have to ask your lecturer, because I'm so not dealing with the basic of AC is quite long, because I'm focusing more on the advanced application of the AC circuits. So bila dah advanced application of AC circuit ni, dia bawah-bawah tu dia duduk dalam kepala dia, quite complicated for me to explain in detail. That's why for the very basic AC circuits, maybe you can ask your lecturer. But in terms of the application of future application or the current application on the AC circuit, maybe I can explain if you want to ask me. Because normally for the very simple calculation, I just give to my PhD student to dealing with. I just take off the very complicated one.
Okay.
That's why sometimes nak terang balik yang asas ni dia dah jadi macam kekok sikit sebab dia duduk dalam kepala. Very hard to explain.
Okay. All right. So no questions, yeah? All right. So, all right, students, I hope you have gained more knowledge about alternating current and terms like capacitive reactance, inductive reactance, impedance are kept close to your heart and mind. Okay, thank you, Professor Nafisa, for sharing your knowledge and experience. It is an honor to have you here. And thank you everyone for joining us today. And on behalf of our organizer, I would like to apologize for any technical difficulties or inconvenience. You may find the attendance link in the live chat after this. Okay, so stay safe and goodbye everyone.
Okay, thank you.
Okay.